Welcome to class. Today's lecture is going to be basic MEP documents and part of this construction management online learning. So let's jump right in. I'm Michael Allison. The basic idea of mechanical, electrical, plumbing documents is I need to discuss this before going into more details on specific systems or components or processes or whatever, right? So we need to be able to find the information on about these systems and about these components. And so today's lecture is really about the documents. All right, well, it might apply really to every kind of construction system or process or component, but and I hope this isn't too much of a going backwards before going forwards, but that's my style. I like to over communicate, so we're going to do that. We're going to look at the mechanical, electrical, plumbing documents, and let's move into that. So first, we're going to talk contract documents. And so contract documents are the documents that actually end up in contracts. And so the the documents might be listed specifically in the contract with the client. Well, they would be. And a good contract with the subcontractor, from a general contractor standpoint, would have the documents listed in the subcontract that this is what they're building. And so just a high overview here in the PowerPoint, and then we'll get in and actually show these documents. So what are the contract documents? The drawings, those are the ones prepared by the design team. And we're talking architects, engineers, interior designers, all kinds of folks prepare drawings. And so those are the documents that were prepared for early on in presented with the client, whatever design team was working with the client, and it went through a whole stage of or phase of design to get to where it is. And we'll talk a little bit more about that here in a second. But so we're talking about the actual drawings, and then we have the specifications prepared by the design team as well. And we'll show you an example of that. But that's a written narrative about what's required for the project. Sometimes there's some diagrams and sometimes there's some photos, but for the most part it's a narrative in the specifications, meaning it's written down, not graphic like the drawings. So now we have another contract document. It's typically in the contract both with the client and with the from the general contractor to the client and from the general contractor to the subcontractor is the schedule, and that's prepared by the contractor, should have input by the subcontractors, at least the principal subcontractors, especially the ones on the critical path. And then I want to introduce you to an idea if you are not familiar with it already. Oh wait, let me go back. So schedule, I'm talking about time, because that the word schedule is especially in the MEP world could be multiple things. So when I say schedule prepared by the contractor, that's the time of the project defined. And then we have delegated or deferred design. Could be deferred submittals, could be, but delegated or deferred design is we'll get into that and we'll show you that in the PowerPoint mode. So I'm just introducing terms, but the contractor is responsible for that. So introduction to terms, now we'll get into details here in a second. So I use the term construction documents, and this could be, I don't know if I'm using legalese or the right wording, but I just wanted to separate the contract documents from other construction documents. Not all documents have the same contractual weight to them. And I would call these documents supplementary information that was derived from the contract documents, from the drawings and from the specifications. So we have product information, product data, shop drawings, manufacturers, installation instructions, samples down there. Those are all submittals. So submittals is a type of information, and we'll get into again more detail. Keep repeating myself on that, but just an overview that we have this thing called submittals, and it could be those types of things. We have additional documents like test plans. We could have commissioning plans. We could have something more formal, inspection test plan, any kind of plan that says this is how we're going to execute the testing or inspections. That's what I'm kind of talking about. We have an extra document there that manages and outlines how that's going to happen. Again, not necessarily a full-on construction document or a contract document like the designer's drawings and specs or the schedule, but it's another plan that shows how we're going to execute some portion of the work. And then have logistics plans down there. This is typically prepared by the general contractor or some other subcontractors, and it could range from things like how we're going to organize the site to how access in and out for different materials, how to organize the inside of the building for both material moving in, staging, and trash out. So this is the basics of a logistics plan. Could show different equipment, maybe a crane spot, all kinds of stuff could be on a logistics plan, and it's meant to be a working document through the project, but that's a critical thing on a large project. I think it's critical on any project, logistics, but typically you don't prepare a plan on a smaller project. Client doesn't ask for it, and so maybe you don't spend a lot of time working to actually prepare a plan. But then you have BIM and VDC, and I keep using BIM and synonymous with VDC. And I know there's some nuances, BIM being the term that's a little bit older, VDC being the more current term. People understand it, but it's virtual design construction or building information modeling. And so we're talking about doing supplementary drawings to the design drawings and the specifications showing how the building's going to function, how the different components are going to come together, coordinating space, things like that. Samples is something I wanted to bring out that it is maybe a submittal, but sometimes it's not. Sometimes it's just something that not necessarily submitted, but we're trying to help the client understand both the texture, the feel, the appearance of the particular product, and so we might have sample upon sample until the client picks out what it is that fits right for the project or their budget or whatever it might be. So now we're in the phase of construction documents, and I'm going back. We have this idea of contract documents, which are going to be listed in subcontracts and contract with the client. And then we have additional construction documents that need to be prepared, supplement the design. And so those documents are used to further plan out and execute the construction. So I want to share some mentor's advice that helped me early on in my career. And this mentor basically was saying, create a routine of regularly reviewing the contract documents. And so I started out in operations, meaning we'd already won the project, we'd already estimated, we already have the project, and now you're executing, you're in operations. And so you could say estimating is part of operations too, but maybe field operations would be the right word. So the point being, coming into the project, it's already been a team's already been involved trying to estimate it, and they know the drawings, the specifications, the construction documents. And this mentor was saying that I need to spend regular time reviewing the documents so that I know what we're building. As at the time, I think I was an assistant superintendent, maybe a very, very green superintendent at the time. I don't remember. But it's good advice, and I try and pass that on to you, regardless of who or what role you're in. Try and become a student of the industry, understand the documents associated with your work, regardless of what position you're in. And so I remember being just a welder, and people say just a welder. Well, that's a skill. That's pretty cool. I was proud of it. That I need to know a whole lot of construction documents and the contract documents to be able to weld. No, not really. But I tried to become a student of the industry, and I loved it later on in my career when when the tradesmen, when we sit in different meetings about maybe pre-installation meeting or a planning meeting of some type, and they knew their industry standards, their construction documents, and tremendously valuable information when the person actually doing the work, um, who I highly respect and love, I think that's great, knows the construction documents. And so whatever role you're in, I think anybody that in a management role in construction should absolutely know the contract documents, and have a habit of reviewing them regularly. And if you're in a role right now of craftsman, start to become, if you haven't already, become a student of the industry and understand both your scope and start to understand other folks' scope. And I'm going to show you some of the documents that you can get to in order to better understand it. So the first thing I said was we were talking about contract documents and dealing with drawings. So we have a set of drawings here, and I've used these before. So this is, I think it's easy for students to understand. I would hope it is. They were talking about a building size that they're familiar with because they go to class, and so you should be somewhat familiar with the building that you're sitting in on a daily basis, or the type of building that you're sitting in, I should say. And so let's look at the documents associated with that. And so I have the drawings right here, and let's just kind of give an overview of how many documents we're talking about. Let's let that load up. So all those are individual pages of this this building's drawing sets. And so we've got, I think, let's see, just shy of 200 pages of drawings for this building. And how is it broken up? It's broken up into general, civil, landscape, basically by the designer, or the design discipline, I think would be maybe more accurate. So civil, landscape, architectural, structural, mechanical, plumbing, fire protection, electrical. Each of these have their own sets of drawings. Right? So architectural's got a bunch. Structural engineers created quite a bit. Mechanical, so on and so forth. They've all got their own drawings. And we're going to get into more detail in the next lecture about reading some of these. This lecture is trying to stay higher level, and we'll stay there for now. Okay, so we've got 195 pages of drawings that we need to be aware of and be looking through the details there. Now let's look at the specifications. All right, the specifications. Well, I said that the specifications were narrative, and you saw that just a second ago, but they are organized by division and section. So when we say Division 0, bidding and contract requirements, Division 1, general requirements, Division 2, existing conditions, Division 3, concrete. Hopefully the idea of divisions is not new to you. There used to be 16 divisions when I first started in the industry, and I have no idea how many divisions there are right now. People commonly refer to the 50 divisions versus the 16 divisions. I know parts of different companies use 16 divisions still. That's fine. It works. Most larger projects nowadays are using the 50 or more divisions. And again, I can't remember how many divisions there are right now, but you get a feel for how this is organized. So as we look at this right here, Division 4 is about masonry, and you can see the section of 04 referring back to the division, and then 2100. I don't know that there's any real rhyme or reason is about why this is 2100, other than I think that it was, you can usually see that they correlate with the 16 divisions, but it doesn't matter, right? So just know that 04 2100 in this case is referring to brick veneer, and we can go find that 0421 0421. Okay, brick veneer. So this is our spec section about brick veneer. Now just kind of pay attention to, I'm going to start with, just give you an overview. We're seeing, okay, related documents, summary, submittals, quality assurance. We require some mock-ups. Let me zoom out a little bit here. It's all text, right? It's all narrative. It's about this product of brick veneer that needs to go on the building. And so I want to show, I think this is really valuable to know how to read or interpret a specification. So let's go back to brick veneer. And notice how 1.1, 1.2, 1.3, these specs are all divided first by division, then by section, and then inside each spec section there are three parts to the spec. Three parts to the spec section. Part 1's general, and might consider it administrative in nature, document heavy in nature, process, talking about overall construction management process type stuff. It's not talking about, well, what it's not talking about is the products, because part 1 is talking about the general things or the administrative things, the construction management type things that need to happen. And then part 2 of the spec, and notice that it goes 1.7. So everything starting with a 1 is general. And they list these paragraphs, and they do this nice little thing to be able to say, if I was talking about given an R fire again and had a question about stain prevention, I'd say paragraph or spec section, what was it, 042100, 042100, paragraph 1.7b1 says protect the base. Okay, that's kind of like the idea why they have that. So you can write this out and tell someone how to get to that specific paragraph or that specific sentence. So the part 2 is talking about products. And so these are the actual products that they're supposed to install. Now, the drawings are sometimes have this information too, but there's more information related to the product that you want to, than the designer wants to actually list on the drawings. It doesn't want to have this massive narrative talking about ASTM C216 grade SW type FBX is required to match a university standard with the compressive strength of this, and the efflorescence. Efflorescence is talking about like inside the brick as it gets fired, there's these chemical reaction. I think it has to do with lime coming out. Anyway, you get this white streaking on the brick, and talking about that. So way more information when someone goes to buy, when they say the subcontractor, the general contractor is going to go buy these, the bricks, they need to buy brick associated with that meets this product specification. So they're going to buy material associated with that matches these requirements. Now part 3 is the execution, meaning how do you actually build it? And this isn't necessarily controlling the means and methods of a subcontractor or trade, but it's telling the designer's telling the general contractor Usually these are kind of like industry standard type paragraphs of generally how to install it. A lot of times they'll say install per manufacturer's recommendations. Sometimes they'll list some sort of industry governing body for millwork or Tile Council of America, install per Tile Council of America recommendations. Anyways, this execution sometimes can be very generic on government jobs, other like federal government projects using it, the UFGS specifications, still using the same format, but they can be very, very prescriptive on how to actually install the material, leaving very little room for contractors' means and methods. So in this one, it doesn't look like it's very, very prescriptive. It's just kind of saying some basic stuff about how to do brick. And it can be interesting reading. Usually what I'm doing as the project manager, and I'm trying to follow my mentor's direction to read through, to understand the contract documents. After some experience, I'd be reading through these specs looking for things that are maybe anomalous or out of the ordinary that the mason maybe wouldn't do normally. When I was first in the trades or first in management, I like reading through this so I could actually understand the language associated with the trade. So one of the cool things about these specs is they actually use the language that's associated with masonry, buttering the corner. And I'd read, I don't know if that's what I read, but just as an example, well, what is buttering the corner? Google, what is buttering the corner? And more times than not, I can find a video on pretty much any of this stuff showing exactly what it is that they're talking about. And then you pretty much understand the specification. It says butter the corners of the joints. Buttering corners of joints are excessive. Furrowing of mortar joints is not permitted. Oh, so they don't want you to butter the joints. That's fine. Okay. Remove excess mortar. Anyway, what I was trying to say was you need to pay attention to what we're in. Part 3, Part 2. Part 3 is talking about how to physically do the work. Part 2 is talking about the products, and Part 1 is talking about the overall processes of the work, over the administrative or management processes associated with the work. All right. So I said that there was a schedule, which was a contract document, and when I say schedule, talking about time, talking about the how the overall duration and sequence to the construction. And usually people prepare that in a Gantt chart. Lots of different softwares out there to do that. Sometimes it's not part of the original contract document as far as the original contract, but at some point in time they have to amend the contract showing with the client what the contract duration will be, what the construction duration will be. And I've seen it also that's not used at all in some residential, some light commercial. They don't use that, or even some larger commercial jobs. The schedule is not a contract document. So if you have a type of contract that's maybe more towards like a time and material type contract, or something where the units are not able to be known in advance, it's difficult to tie in a schedule if you don't know exactly how much you're going to be moving. Anyway, demolition's a good example. Sometimes people don't know exactly how much material is in there. Sometimes you do. Retrofits, stuff like that. Sometimes you get a schedule, sometimes you don't, depending on, again, how sophisticated the client is and how detailed out the drawings are, how much information is known in advance. Could you plan it out with the information known? Could you not? All depending on whether you get a schedule or not. I'm not going to talk about schedules much in here other than to say that was a contract document typically, but I do want to show you the other one that I was talking about. And so let's go to, I think it would still be in general, probably on the next page. Yes, it is. So let me zoom out so we know what we're talking about. I'm on the second page of the drawings. You can see here I'm on the second page of these 195 pages. And on the second page, it's telling you what's included in the design. You can see, okay, here's all these pages that are included in the design. Here's their code analysis. Here's a bunch of symbols and the design team and all the abbreviations they're going to use in the drawings. Well, the sheet numbering, how to read the drawings, location. Well, there's this happy little thing down here called deferred submittals. And so this is saying that the contract, let's just read through it. The contractor is responsible to submit deferred submittals in accordance with the IBC, blah, blah, blah. Deferred submittals are to be supplied to the building official for review with an accompanied letter from the architect stating that the drawings are in conformance with the design. Work related to the deferred submittal is not to commence until the building official has approved the submittal. Well, why would the building official need to see this? If they're talking about submittals, submittals almost always go to the designer. Well, that's not true. You could have a lot of, you could have a municipality that has a civil or other infrastructure type submittals like asphalt or water line, and all those types of submittals often go to different parts of the city. Jurisdictional parts of the city or county, whatever. But the vast majority of submittals really just go between the design team and the general contractor. Sometimes the client's involved, sometimes other parties, but the general rule is submittals are going between the contractor and the designer. So what is this saying? Well, this is saying that they're actually describing here one of the processes of the design to be able to be built is to have it be reviewed by the jurisdiction having authority, by the building official for review, meaning they don't have a permit necessarily. I don't know if permit's the right word, but they don't have approval to build these things right here because it hasn't been fully designed. Or yeah, I think that's fair to say that the design is not complete on the precast concrete stairs. The design is not complete on the brick veneer. The design is not complete on the exterior ornamental railings. And that's what this list is saying, is that they've gone to the point of trying to design this with 195 pages and what was the spec? 1,651 page spec book. But they're saying that the design is not done. And maybe design's not the right word. Maybe drawing and calculations might be more accurate, because they probably have some sort of like overall design concept for all these things, but the engineering behind them hasn't been done. Or so the fire alarm system has a concept in here in these drawings and in the specs as to what they want, but the actual engineering and design of the fire alarm system has not been done, and the designers know that this has to go back through, this fire alarm system has to be completely finished with the design and then go back through the typical design process of going to the architect, going back to the city, getting the city's review and comments, and then coming back to the general contractor, say this is approved to build. And there's quite a list here, right? There's quite a bit of stuff that has not been completely engineered yet and ready for construction. You have to assume that the rest of the drawings that are here is exactly what the client wants. The specifications that are done is exactly what the client wants, but you have to understand that these are not. So when I said like contract documents, I would say it would be fair to say that there are contract documents yet to be done, yet to be approved, that still need to go through some process in order to be on the same level as a contract document. And then say the fire alarm system gets fully engineered, then that's going to follow more of the submittals that we were talking about. Okay. Sorry this is dry. Contract documents, construction documents can be a dry topic, but you need to understand it. So let me show you an example of, I think I'm done with the idea of contract documents. So contract documents, drawings, specs, schedule, and then I'm going to lump deferred submittals in there as well. We'll talk about, we should probably talk about code right now. So, we'll do it later. Code is another on the level of the design documents that has to be done that way. You have to build it per code. Okay, let's go look at the next piece that I was talking about. Let's go look at submittals, product data, shop drawings, those kinds of things. Okay, here is some product data, some product information relating to the project. It says the plumber is going to install this. Well, it's a LK product. It's LK luster tone stainless steel single bolt undermount sink. This is the model number, and this is the basic information associated with this this sink. So I don't know what the design team actually called out, but the point is the subcontractor has given this submittal, this information to the general contractor, saying this is what we understand the design documents, the construction, the contract documents to say to provide, and we're going to provide this one. Now it may have just said, sometimes the specs are super prescriptive, and it may have listed LK luster tone stainless steel single bowl undermount sink model that, or it may have just said stainless steel bowl undermount sink meeting I don't know, ASME that. They may have just said that in the specs. And we can go look that up and go see what it says. But the point being, sometimes the specs are super prescriptive, but this would have been in part 2 of the spec, or it would have been somewhere else in the drawings, like a schedule saying this is what they want. All right, so this is an example of product data. Here's an example of, I would say, product data, sort of shop drawing, sort of between the two, mostly product data. But this is for equipment. And we've got these Mitsubishi cooling and heating VRF equipment that they're going to provide. And so this is the main pieces of how the building gets heating and deals with heating and cooling. And it's showing you all this information, is what it looks like, and then a whole bunch of information about it, and then a little drawing saying this is the actual physical dimensions. So this is 97 pages of different pieces of equipment, mechanical equipment, that's going to be a part of the heating and cooling of the project. They've got a few shop drawings in there. Anyway, you kind of get a feel. So this is extra information in addition to the drawings, in addition to the specifications, that we should be familiar and be able to read it, understand what it is. And sometimes, I gotta be honest, man, I've been in the industry what I feel like is a long time. There's still shop drawings, there's still product data that in all kinds of things that somebody has done in a unique way, and I don't understand what it is, and I'm gonna have to call up the vendor and have them explain how to read this thing. I was just doing it the other day with a set of what I thought would be super simple windows, and my goodness, I could not understand heads or tails of how their product data literature was supposed to read. And so door hardware is like that too. It's just, oh man, reading door hardware. Hopefully you're smiling right now, so you know exactly what I'm talking about. But some of these mechanical, electrical, plumbing can be very difficult. Some of them aren't. That seems pretty simple, right? It's just a sink. What's this one? Place to fill up your water bottle. Just I don't know, just pretty simple stuff here. This is not hard. But what would I necessarily need this for? Well, this is telling me that this is 115 volts, 60 hertz, so it's only requiring that voltage. It should somewhere in here show like the mounting height. Okay, it's a wall mount, so we're gonna need some backing. Here's the approximate weight. Um, so some basic information on how to do this. So we'd need to know. Uh, let's see if there's any mounting instructions in this one. No mounting instructions. We might need to pull up the manufacturer's installation instructions to see exactly what we need to have in the wall in order to have this be secured to the wall. But this should be enough information to get this approved. This is what the subcontractor wants to buy and install on the project. It's going to go through the submittal process. The engineer is going to review it, maybe the architect, but most likely the plumbing mechanical engineer. Okay, so that's supplemental information. Here's a shop drawing. So this is the fire sprinkler shop drawing, saying this is how they intend to run all the piping for the fire alarm, for the fire suppression system. And we can dive in here, right? So this darker line, they've grayed out everything else that they don't want, and I assume these are either heads or drops or both. So you can see that they've detailed out how they're going to run all the sprinkler lines throughout this space. And this is the shop drawing, and it's showing actual lengths. It's showing yeah, I'm pretty sure that's a drop of 1 foot. Oh, and 3.5. Oh no, drop 1 0 foot 3.5 inches. That's just a little stub coming down, something like that, with a head on it. And they can see like the little joints are there. Another head. So that's all coming down just like 3.5 inches in this space. Let's see if we can find one that's dropping even more. These are dropping 5 inches. So the pipe's running this way, and then a pipe goes down. Anyway, so this is the shop drawing. This is more information. So if I was trying to do any kind of scheduling and sequencing and contract so after the contracts are done, scheduling, sequencing, coordination, this would be a very important document to be able to have my hands on. If I was trying to do any quality control after the fact to see if they built it the way, this document is super important. Very good information in here. And that's a shop drawing. It looks like a construction drawing, and I bet the reality is they took the drawings from the design and did a copy of, basically it looks like the reflected ceiling plan, pasted it on this, and then drew out all their fire sprinkler lines. So we've got plumbing, shop drawings. There's a bunch of mechanic. Okay, we already did that. Specifications. Okay, now we're looking at the other end of the spectrum a little bit here. We've got a set of drawings with 195 pages and specifications at 1,651 page spec book. Let's look at what that looks like in not that world. So now that we're dealing with a 5-plex that we're getting built, and there are only 30 pages of drawing contract documents. There's no spec book. The spec book is actually right here in the drawings itself, right? So if we're dealing with a maybe a basic home, and you might have a basic spec home might have 8, 9 drawings, maybe not even that. And so the the point being, the spectrum is pretty wide between what is what level of design is done, how sophisticated is the project, how much information is there. There's in this fiveplex here, there's quite a bit of information, but there's, as we look through it, there's doors, drawings. I mean, they have the basic stuff, but here's an electrical plan here, electrical notes, plumbing notes. This is basically what we got for this project. There's not a lot being called out here, and so what's going to govern? Code is going to govern a lot of this. And so we talked about code. We're going to be dealing with IBC, UBC, IRC, mostly IRC in this one because that's the International Residential Code. It could be NEC, National Electric Code. But basically the jurisdiction having authority and these notes are what govern this set of drawings. So I think that's what I was hoping that folks would get from this, is to understand that there's more documents than just like a set of drawings, more documents than just maybe a spec. And I think this is the some of the more challenging things for folks to when people are moving from one position to the next, even myself having to learn what documents sort of govern. Well, the contract documents govern the most, meaning the drawings and the specifications. That's what we're contracted to build. Unless there's a change to the contract through some sort of modification, change order, whatever process you want to talk about there, that's fine. But until they're changed, we're contracted to build what's on the drawings. The supplemental information, both submittals and shop drawings, manufacturer's literature, that's all meant to be able to help us build this, but it should not necessarily supersede the drawings. But what it can be is what I've seen a lot. Let's just go look at this real quick, give you an example. All right. I did a project not too long ago where the architect had some basic details like this about the window system, glazing system. I know this is an MEP class, but I want to be able to show an example, because I think if I gave an MEP example right now, it'd be too hard, because we're not into the actual details of all the components and systems yet. So let's just do something about a window. The architect draws it something like this, but the system that the owner picked is not this. This is more drawn as if it was storefront. But they picked out more of like a pre-manufactured window system. I forget the manufacturer, it doesn't really matter, but something more with like tabs. So it has, oh, I need the other drawing. So the actual window system would fit more like that, and there would be a little fastener right there, right? And so kind of a different system than what was drawn in the drawings. Doesn't mean that the contract documents, these drawings now govern exactly how this was supposed to go together. No. Not the design intent was that we have a window system here with metal drip edge, and we have it. So we might have a little bit of a coordination to do, but that should be done through submittals with the engineer, and the architect in this case, and show them we've got a different system that the client picked out than what's actually drawn. And so some of these flashing details might have to change, and we might have to follow the manufacturer's literature rather than what's shown in this. And they would be fine, the architect engineer would be fine with that kind of stuff. That's what you're supposed to do. The might be less enthusiastic with you if you didn't follow any submittal process. They had this designed. They're responsible for how, from a design standpoint, and they have insurance and stuff saying what happens if this fails. They may have spent a really long time trying to figure out how to seal up this building, put this detail together, and then we don't follow it because we let some manufacturer's product data override that. They might not be happy. They might be, I don't know, depending on what the situation was. But the point is, there's submittal process. There's RFIs. There's other ways to be able to get the engineer and designers involved on approving more information to be part of being built off of. But the original drawings are what we've been contracted to. So they have to work together. The point is those documents, while they might not seem harmonious or synchronous, they really are when you go through the processes that you're supposed to go through. Okay, we'll end there. Thanks for joining me. We'll see you on the next one.